Welcome back to the Bhairavan channel. Today we will be talking about chemical bonding. Very important topic for your board exams as well as your other competitive exams like NEET, JEE. So please let us try to understand chemical bonding very well. Now before going to understand chemical bonding, let me explain this term bond. What do you mean by bond or bonding? Bond, how can we define bond? You see, in very simple terms, whenever I say bond, bond is an attractive force which holds two things together. For instance, if somebody hurts you, your parents will feel very bad, is it not? So what is there is no physical, so-called physical connection between you and your parent individually, but you have a very strong bond between them, is it not? So that bond will hold you and your parents together always, right? Similarly, even two chemical species are held together by a strong forces which are called bonds. We will talk about it in a very interesting manner. So let me try to help you to understand different types of bonds. So we classify bonds based on the nature of the attractive force which holds them together. So let me write the basic types of bonds and then we will try to understand the science behind the formation of bond. Now what are the different types of bonds? So let me write it down. So bonds, what are bonds? Bonds are attractive forces. Bonds are attractive forces which holds two chemical species together. Two chemical species together. Now, how many different types of bonds do you have? We have a lot of bonds. I will try to explain each and every possible bond one by one. So, first among them is called ionic bond. Now, we will try to understand what is ionic bond. Now, before going to understand ionic bond, I have to tell you a few things. Now, let me take example of a noble gas, like say neon. So, atomic number of neon is 10 and its electronic configuration is given by 2,8. This is called Bohr's electronic configuration. If you write modern electronic configuration, your modern electronic configuration will be 1s2, 2s2, 2p6. So both of these configurations indicate that the valence shell has exactly 8 electrons in it. So this is a very important conclusion. So whenever you have 8 electrons, see, that will give rise to a noble gas or noble electronic configuration. What is noble electronic configuration? Noble electronic configuration is having 8 electrons in the valence shell. Now, let us try to understand this noble electronic configuration a bit. Now, you people like, lot of people, is it not like? You people like, cricketers like Mahendra Singh Dhoni, like Sachin Tendulkar. You people also like lot of, Bollywood heroes, Hollywood heroes, is it not? Now, when it comes to liking heroes, when you go and watch their film, what do you tend to do? You tend to behave like them, is it not? Similarly, any element possessing these 8 electrons will tend to behave like noble gas. So, having 8 electrons become very important. So, this having electron is a major factor for formation of bond. That we will see while explaining the science behind formation of bonds. We just have understood why 8 electrons are very important in the valence shell. Now we will try to understand how the elements will try to get 8 electrons, especially forming an ionic bond. We have already understood the importance of having 8 electrons in the valence shell. As I have already told you, that will make an atom to behave as if it is noble. Now, let me take an example of sodium. Sodium atomic number is 11 So your electronic configuration is say 281. And if you take chlorine, chlorine has 17 electrons. Its electronic configuration is 287. So this is your Bohr's electronic configuration, and if you write modern electronic configuration, it will be 1s2, 2s2, 2p6, 3s1. Now modern electronic configuration of your chlorine will be 1s2, 2s2, 2p6, 3s2, 3p5. Now, when you see the electronic configuration, since both of them need 8 electrons to behave like a noble gas, so if you see sodium, this is its valence shell. Valence shell in the sense outermost shell, you have it here for sodium and you have it here for chlorine. So you can see clearly from the electronic configuration that sodium has in the electronic configuration, it is very clear from the electronic configuration that valence shell of sodium contains 1 electron, whereas valence shell of chlorine contains 7 electrons. So if sodium has to attain stability, it has two choices. One, give away 1 electron. If it gives away this electron, you can see here you have 8 electrons over here, thereby it attains stability, whereas chlorine, it can take 1 electron or it has to lose 7 electrons. Sodium, either it has to give away 1 electron or take 7 more electrons. Now, which is the very simplest way? See, sodium finds losing 1 electron to be more beneficial. Why? It is very clear, as we already know, that the nuclear charge of sodium will be 11 plus. If it has to gain 7 more electrons, this nucleus will not have capability to hold. So, the only way out for sodium to attain stability is by losing 1 electron. Whereas when you come to chlorine's case, chlorine has 17 electrons. So, chlorine nucleus doesn't agree to give away 7 electrons. But it can afford taking 1 more electron. So, what will happen? Your sodium will evidently transfer 1 electron to chlorine. Now, if you write the structure, if I write the representation of the atom of sodium as well as chlorine, and if I try to understand, it looks something like this. See, 11 positive charges in the nucleus, and this is supposed to be the first shell, which is K shell, and you have only 2 electrons over here, and this is supposed to be the second shell, or L shell, you have 8 electrons over here, and yes, this is supposed to be the M shell, and you have only 1 electron over here. This is your sodium. Now let me try to write the chlorine. Chlorine has 17 positive charges, and this is supposed to be the first shell, this is supposed to be the second shell, and this is supposed to be the third shell. So first shell contains 2 electrons as we have written here. Second shell contains 8 electrons. And the third shell contains 7 electrons. So each of this dot represents an electron. Now, what exactly is happening is your sodium, of course this is chlorine, yes. So your sodium is completely transferring one of its electron to the chlorine atom. Now when your sodium transfers one of its electron to the chlorine atom, then what will happen? What will be the resulting electronic configuration? Resulting electronic configuration will be somewhat like this. See, resulting sodium electronic configuration will be, 2, 8, 0. And modern electronic configuration will be 1s2, 2s2, 2p6. This is 11 plus. So you can see here clearly, your number of electron is 10. 2 plus 2 plus 6 is 10. Whereas number of positive charges are 11. So what will be the net charge? Net charge will be positive on chlorine. Now, if you see the chlorine which has already gained an electron. So once chlorine gains an electron, we don't call it as chlorine anymore. We call it as chloride ion. So how will it look? See, chloride ion's structure will be somewhat like this. 2, 8, 8. So the 7 over here will become 8 over here. And your electronic configuration, modern electronic configuration will be as follows. So there will be formation of two charges. Now let me write it. Let me write it schematically again over here. So your sodium will become somewhat like this. 11, first shell, second shell. So in this first shell you will have only 2 electrons. In second shell you will have totally 8 electrons. Sodium has achieved octet and your chlorine will be somewhat like this. So in the first shell you will have 2 electrons and in your second shell you will have 8 electrons. Even in your third shell you will have 8 electrons. So overall charge of the chloride ion will become negative. Now remember, the sodium as well as chloride ion has achieved their stability. So what is the consequence of achieving stability? These both are charged. Consequently, they should attract one another. So when they attract one another, what kind of bond do they form? Remember, they are ions. And the bond formed between the two ions is called ionic bond. So ionic bond is a consequence of forming octet. And always remember, the positively charged ion is always called cation and negatively charged ion is called anion. And do remember this, the cation will be much smaller when compared to sodium, Na plus ion. For instance, here Na plus ion is much smaller when compared to Na. Why is it so? Because you have removed an electron. Whereas chloride ion is much larger when compared to chlorine. Why is it so? You have added. When you add, what will happen? The effective nuclear charge in atom decreases, thereby charge or the size. Charge increases and the size of the atom, the overall size of the atom increases. Please subscribe and support for more such videos, and of course for part 2 of chemical bonding, please subscribe and support. Thank you.